Okay. Good morning, all of you. Welcome to this 23rd lecture of refrigeration and air conditioning. I am Professor Digvijayange. So, in the last lecture, what we have done, we have taken MCQ test of chapter 2. So, up to now, we have finished the first chapter, uh, and then we finished the second chapter. So, what we have studied up to this, we have studied what is the vapor compression system and what are its components like evaporator, condenser, compressor, etc. But we have omitted various components in it. So apart from condenser, compressor, and evaporator, there we have piping. So the pipes are used to carry out to make a easy flow of the refrigerant. Then yes, next thing we omitted, that is refrigerant. So refrigerant is the what you call blood of this VCR system. It carries the heat and it dissipates that heat into the atmosphere. Then we started we there are other components also in that, like accumulator it is there, receiver is there. Apart from this, insulation is also used for copper piping. So that industry is also in plays in millions of dollars, insulation industry. So these are some small components from VCR system. Those are individual. If you manufacture them, they have huge scope. Like if you go for copper piping, if you go for insulation, that also has a good market. So our third chapter deals with the refrigerants. So what kind of refrigerants are used? So up to this, we have studied we can use air. So in first chapter, we have studied that air refrigeration system in which we have used air as a refrigerant. And in water also can be used as a refrigerant because water also carries the heat. So any fluid that can carry heat from one to another, that we can use as a refrigerant. But when we talk about commercial refrigeration, in which we need very low temperature, suppose temperature falls below 0 degrees Celsius, in that case we cannot use water because its freezing point is 0 degrees Celsius at 1 bar. Also, refrigeration systems, those also cannot be used very low temperatures. So when you have this temperature requirement in your industry, so that time various refrigerants has to be used. Now there is also one more thing it is there, that you cannot use same refrigerant everywhere. So depending on the application, so suppose it is a pharmaceutical industry, or it is a milk dairy plant, or it is a cold storage. In that case, various refrigerants are used. So you cannot use the same refrigerant everywhere. So it depends on the application. So give the title. Our third chapter, it is refrigerants. So we'll see what are the types of refrigerants, how they are classified, what is the nomenclature it is used. So give the title, refrigerants, and this is its syllabus. The syllabus is classification and desirable properties. So how these refrigerants are being classified? So you can see that image on the right. So these are the cylinders used for refrigerants. So why we need refrigerant cylinders? Why cannot carry that refrigerant in an open bag? Because the refrigerants are stored under pressure. Okay, so when they are under pressure, so they are stored in the form of liquid. So this is like same as our LPG cylinders, what we are using in our household applications. Refrigerants are stored under the pressure in the cylinders. So you can see that on every cylinder, so different number is given. So it starts with R22, R22, then it is R134A, R404, R410, R407, R507. So these are all refrigerants which are stored in the cylinders. Okay, so when you assemble your VCR system with a condenser, compressor, and evaporator and other components, and you complete the piping and you seal the system, you make it leakage proof. That time, what you do? So this refrigerant technician, they use this cylinder and they have this injector. So they inject this refrigerant into the system. That is called a charging. So the system is charged with refrigerant, then it can be used. The second is nomenclature of refrigerants, selection of refrigerants. So selection means what are the properties of refrigerant. Based on these properties, we are going to select the refrigerant. The next is secondary refrigerant. So this is there is a classification like primary refrigerant and secondary refrigerants. Effect on ozone depletion and global warming, total equivalent warming impact. Okay, so this issue has been there in from last 3 decades that refrigerants they are causing ozone depletion. That is why several refrigerants we are not using anymore. And there is this global warming index GWI. So it is said that refrigerant should have low GWI, low global warming index. And last is alternative refrigerant. So various research is being going on in this field. So this is the field refrigerant in which a thermal engineer works along with the chemical engineer, and they manufacture refrigerants required according to the requirement. Now they are going for natural refrigerants. No doubt that we have air and water which are natural refrigerants, but they are looking for these refrigerants which will have zero impact on our environment. So previously they were using CFCs, but CFC is called chlorofluoro carbon. So they cause this ozone depletion. So in that case, they are being banned. Now we are going for natural refrigerants, which are like nearly zero impact on our environment. So this is our syllabus. First we'll study what is its classification, what are the properties. Then we'll see how they are numbered and what is the reason behind their numbering. Okay. Then we'll see some applications of it. So before we go into actual chapter, I want to make you aware of one excellent online platform. So this is a Danfoss online learning. Danfoss is a MNC company in the field of refrigeration and air conditioning. They are global manufacturers of these components. Danfoss, Carrier, all these are huge market leaders. So Danfoss provides this online learning in the field of refrigeration and air conditioning. So you can go to this website danfoss.com/learning. There you can see various modules are there. So these are like very small modules. So within 4 days also you can finish. So I have enrolled for this cold room module. It is like for 4 days. It is very good. You can check it out. But you need a laptop because they are using this Adobe Flash player, but it cannot work on mobile. But so that you have to use the laptop. So Danfoss online learning not only gives you theoretical knowledge, but they also provide this industrial knowledge about how to install and service Danfoss products and gain new skills and earn completion certificates. So they are providing certificates if you complete their module. Okay, and get direct access to Danfoss expert. So time being, you open this account Danfoss. So you complete some modules, and there is job portal also. In the job portal, if you like subscribe, so you will receive this notification time to time. Okay. Similarly, Carrier also has some learning modules, but I have not checked it. Carrier company provides the softwares, commercial softwares, if you want to calculate the heat load calculations for a building or a room. So Carrier is providing one software called HAP, hourly analysis program. So HAP is commercially used to carry out whatever heat load is there inside a building, and then they are designing the system components. Okay. So that part we'll see in our second section when we'll study air conditioning. So yes, in this chapter we are going to deal with some ASHRAE standards. So first ASHRAE standards. So ASHRAE, as you know, I have taken one webinar also. It is the American Society for Heating, Refrigeration and Air Conditioning. So ASHRAE works. ASHRAE has this R&D cell, so they work continuously in the field of this energy conservation, how we can reduce the energy load on a building. So it provides standards for air conditioning as well as refrigeration. So it actually is providing standards for refrigeration. So sorry, refrigerants. First is ASHRAE standard 15. Its version is 2060. So it provides safety standards for refrigeration systems. So what happens? These refrigerants are somewhat toxic, somewhat flammable also. They can catch fire. So this standard is related to that. It is directed towards the safety of persons, a property on or near the premises where the refrigeration facilities are located. So that is ASHRAE standard 15. Please write it down, and you can search online also. Second standard, it is ASHRAE standard 34 version 2016, and this is like related to classification and numbering of refrigerants. Okay, so first is like designation and safety classification of refrigerants. So ASHRAE is mostly concerned about this toxicity and flammability of refrigerants. We will see one table in which this toxicity and flammability, these things are given. Okay. So primary components under this standard include numbering and designation of refrigerants. Second is safety group classification. And third is refrigerant concentration limit. So how much should be the concentration? If you are going for blending, if you are like blending two or more refrigerant, in that case, what should be its concentration? Okay. So those who are like members or have the account, so they might get notification time to time. So Azure provides this education and training. So if you are want to learn more about refrigerants, so this is our third chapter, refrigerant. If you want to learn more about this, so Azure provides one e-learning module in this case. Okay, so there is one program, refrigerants literacy, in which you will study like it is like our syllabus only, refrigerant types and environmental considerations, refrigerant classification including ASHRAE standard 15 and 34, refrigerant selection and refrigerant management. So if you want to learn more about this chapter in detail or about the standards, in that case, you can log in into the ASHRAE and you can do that course. Okay. So it is not free, obviously, because it is a professional course, so that will charge you some amount. So not only this, if you go for educational training, there also it provides trainings on this vapor compression refrigeration cycle, and how to select like what are the types of compressor evaporators, how to select them, like what are the copper pipings, what is the insulation provided. That also you can check. Okay. Now we'll see some like market leaders who are manufacturers of refrigerants. So key market players in this field, first and the most important, it is Honeywell International, this from US, because Honeywell, if you have heard, Honeywell is a very big company, MNC company, and Honeywell International is a market leader in the production of refrigerants. Then comes the Chemours. This is also very big company. Then we have Daikin, and Arkema is also very good company, like big company in the field of manufacturing of refrigerant. So Honeywell, Chemours, and NK, they are the like market leaders in the field of refrigerants. So I will give a slight idea about this. So this refrigerants market size is estimated to be US dollars 22.9 billion in 2018. Okay, so you can imagine what is the this market size. It is in like billions, 22.9 billion, and it's projected to reach US dollars 31 billion by 2030. Okay, so there is a huge market and huge opportunities. if you want to do some work in the field of refrigerants. At the CAGR, so this is like a compound annual growth rate of 6.2 percentage between 2089 2023. So this CAGR is in financial terms. So it's actually if you want to calculate how much interest rate of investment done in some several years. So if you want to take the rate of investment in 5 years, so CAGR will give that idea like it is increasing or it is decreasing. Okay. Okay. So coming to the topic, refrigerants. So refrigerant, what is a refrigerant? It is the primary working fluid used for absorbing and transmitting heat in a refrigeration system. So in first chapter, I have given you that analogy of water pumping. In that example, we have studied that there are like two reservoirs. One reservoir is on ground level, another reservoir is at top level. If you want to carry water from lower to upper, okay, so you will need some work. In that case, we have used water pump. But another thing in that was if you want to take water from one reservoir, its level should be below the level of the reservoir. So that was a case of water pumping. Then I have used that analogy for refrigeration. Similarly, if you want to transfer heat from lower temperature reservoir to higher temperature reservoir, in that case also you need a external work. So that external work, what we calling it as a compressor work. Again, that case also, if you want to transfer heat from one reservoir to the like whatever working fluid, that is the refrigerant we are using, that refrigerant should be at lower temperature because heat flows naturally from higher temperature to lower temperature. आता बहुतेक मुलांना हे कन्सेप्ट समजतच नाही की सर हीट कुठून कुठे वाहते काय समजतच नाही. So remember that heat naturally flows from higher temperature to lower temperature. If you put a glass of water which is at suppose 80 degrees Celsius and so keep it open in the atmosphere, okay, on your table, so automatically after some time that water will get cooled. What is happening in that case? That it is dissipating its heat into the atmosphere. So that is why the heat flows from higher temperature to low temperature. But if you want to reverse the direction, if you want to transfer heat from low temperature to like higher temperature, in that case, but you will require some external work. It cannot happen on itself. So that is why we have a clause statement. Clause statement says that if you want to transfer heat from low temperature reservoir, that is sink to source, in that case you will require some external work. Okay. So refrigerant is that carrying medium to carry heat from one reservoir to another reservoir and dissipate into the atmosphere. So we need a carrying medium. So that carrying medium is refrigerant. Okay, so I'll read it again. If you want to write, you can write the definition. So refrigerant, it is the primary working fluid used for absorbing and transmitting heat in a refrigeration system. Okay. So I will read it. In principle, any fluid can be used as a refrigerant. So we have already seen we can use air also as a refrigerant in air refrigeration systems. Refrigerants absorb heat at lower temperature and low pressure and release heat at higher temperature and higher pressure. So we have seen that in first chapter as well as in second chapter. So refrigerant is absorbing heat from evaporator. So evaporator, what is the function of evaporator? It takes the heat from the space. So space can be a fridge, it can be a room, it can be a warehouse. In that case, we are using this evaporator. So evaporator will take that heat from the room or the warehouse and that heat is taken by the refrigerant. So in that process, refrigerant undergoes the phase change process. So at the start of evaporator, we have liquid or liquid plus somewhat vapor refrigerant. So when it takes the heat, it takes the latent heat and it is converted into vapor or superheated vapor. Then that heat is transferred into the condenser. So in condenser also it takes the high pressure, high temperature vapor and it undergoes this heat transfer process. It releases its latent heat into the atmosphere, and what we get at the outlet of condenser, it is a liquid uh, refrigerant. Okay. So if you use like a liquid subcooler in that case, so we'll get a subcooled liquid. Okay. So refrigerants absorb heat at low temperature and low pressure and release heat at at a higher temperature and higher pressure. Typically, refrigerants undergo the phase change during the heat absorption, that is evaporation, and heat releasing. So typically, refrigerants undergo phase change during heat absorption and heat releasing. So that is what I told you previously. Phase change is must if you go for refrigeration. Air used in an air cycle refrigeration system can also be considered as a refrigerant, but there is no phase change. So that is why like that puts on limitations on air refrigeration cycle. Okay, so air cannot undergo phase change. It cannot solidify or it cannot freeze. It cannot liquidify. Okay, so it is always in the form of gas. But we are using air as a refrigerant in air refrigeration system. Now in this chapter, we will focus on those fluids that can be used as refrigerants in VCR system only. So we have a separate chapter, next chapter, that is vapor absorption system. But in this chapter, we study the refrigerant. Those are used in this VCR systems only. Okay, so I'll repeat this definition again. Refrigerant is the primary working fluid used for absorbing and transmitting heat in a refrigeration system. So what you see on the right, so there is a iceman. He is the driver of the truck, and the truck is of ice. So it is like means that driver itself is made up of ice. Okay. Okay. So this is about the introduction. We are dealing with refrigerants. So these are the heat carrying mediums, and it is expected that they undergo some phase change process. But it is exception. It is there that air does not undergo any phase change process. Okay. This is a primary classification that we'll see. So refrigerants are classified as primary and secondary refrigerants based on their applications. Okay. So we'll see what is a primary refrigerant. So primary refrigerants are those fluids which are used directly as working fluid, for example, in VCR and absorption based systems. So there is a term called DX and chilled water systems. Okay, so but I'll connect my tab. Okay, so commercially, these systems are classified. First, it is the DX system, that is the direct expansion, and we have second, that is the chilled water system. Okay, DX systems are those like they use this primary refrigerant. In this case, what is happening? You are using directly evaporator. In that case, air comes in contact with evaporator. That air is cooled, and that air is used for air conditioning or the process industries. In chilled water system, what is happening here? We are using evaporator, no doubt, but that evaporator is used to lower the temperature of water. So that water is called chill water, and that water will be used to cool the air. Okay, so in case of DX, what is happening? We have evaporator, which is directly coming in contact with air. In chilled water, what we have is evaporator. Yes, we have this VCR system, evaporator. It is cooling water, which we call it as a chilled water. Then that water will cool air. So this is the difference between DX and chilled water system. So in this case, water is called as secondary refrigerant. And this evaporator will be called as primary refrigerant. Okay. So I'll read it again. So primary refrigerants are those fluids which are used directly as working fluids. For example, in VCR and absorption based systems, these fluids provide the necessary refrigeration by undergoing a phase change process in the evaporator, absorbing latent heat. Okay, this is very important. So they undergo phase change process, absorbing latent heat. So this is our primary refrigerant. So it is based on the application. Okay. So on the right side, we have secondary refrigerant. So I'll read it. Unlike primary refrigerants, secondary refrigerants do not undergo phase change. They transport heat from one location to another. So as I said here, water is a secondary refrigerant. It does not undergo any phase change process. So what is happening in this case? Sensible heating or cooling. Right? But this primary, it undergoes phase change. Okay. The commonly used secondary refrigerants are the solutions of water and ethyl glycol, propylene glycol, or calcium chloride. So in general, it is called as brine water. Okay, so these solutions are known under the general name of brines. Okay, so that brine is used, and that cooled water we're calling it as a chilled water system. So if you use that chilled water for your air conditioning or refrigeration application, in that case it is called as chilled water system. Okay, so its purpose and used commonly. So these are used as brine. It reduces the extensive circulation of the primary refrigerant. Okay, so this I will explain in the next slide. So how it will reduce the extensive circulation of primary refrigerant, that I will show with the help of diagrams. Okay, so we'll start with yesterday's MCQ. So yesterday in our test, we had one MCQ in which you asked that what are the desirable properties of the refrigerant. The correct answer that was the high critical temperature and low freezing point. Okay, so why it is that? So I will draw one pH diagram here. So here it is a pressure versus enthalpy, and this is our pH curve. Okay. So here we have a saturated liquid curve. This is a saturated vapor curve. And here we have a critical point. So I'll draw one process of VCR. So I'll start with suppose point here 1. This will undergo compression. Then this is the condensation, isenthalpic expansion, and evaporation. So this is the 1, 2, 3, 4. Okay. So as we move up in this chart, if you 1 to 4, it comes out to be here. So this is like 1 dash 4 dash. If it come down to here, 1 dash double dash 4 double dash, you can see that this length, that is a latent heat. So what we call here, it is as a enthalpy at fluid, and this is enthalpy at gas. and this difference in between we are calling it as a HFG. You can see that as this pressure is increasing, that HFG value will decrease. So you can see that length of this HFG is getting reduced as we go near the critical point. So what is the critical point? So critical point we have studied in your ATD also. So in critical point, what happens that fluid or the liquid is directly converted into vapor. So there is no phase change process. Means there is no absorption or a release of latent heat. What is happening here? That liquid is like directly converted into vapor. But this is not desirable in our application. रेफ्रिजरेशन मध्ये काय पाहिजे फेज चेंज प्रोसेस पाहिजे लॅटंट हीट ऍब्सॉर्ब केलीच पाहिजे. In that case we should have a high critical point. High critical point means it should have high critical pressure and critical temperature. Second thing is low freezing point. Okay. So it is very logical that refrigerant should not solidify. जर ते solidify झालं तर it will obstruct the flow inside the circuit. त्यामुळे सगळं ते circuit fail होऊ शकतं जर ते solidify झालं तर. So that is why it should have low freezing point. So even if you are using an application, suppose for minus 30 degrees Celsius, in that case, that refrigerant freezing point should be like around minus 60 degrees Celsius. That means at minus 30, also it will remain as a liquid. Okay. So this is the concept of high critical point and low freezing point. Don't worry. So we'll study this in our next lecture when we'll study the properties of refrigerant. So first I will show you the DX system, and then we can go for chill water system. So that way you can understand the primary and secondary systems. So suppose I have one room here. So this is a room, and this is a false ceiling. Okay, so some terms I will tell you. So what you see here, this we call it as a FFL, finished floor level. If it is a first floor, second floor. If it is on ground, so we can generally call it as a ground level. Finished floor level. Then this is a false ceiling, and this is a soffit of slab. This is called as soffit of slab. This is a false ceiling. Okay, so what we are doing here, so we have a VCR system. Or shall I draw this on next? So I will draw this diagram on next slide. Okay, so I'll draw a big diagram so that you will understand. Okay, so this is a finished floor level. This is a false ceiling level. This is a soffit of slab. Okay, so for a room, so this is a room. I will have one AHU. Now, what is the AHU? AHU is a air handling unit. So generally, they are using AHU or either they are using FCU, fan coil unit. So those are like air delivery systems. ठीक आहे हे असं काहीतरी AHU चा बॉक्स असतो मोठा. So here we have filters to filter the air which is coming inside. Then we have this heat exchangers, small heat exchangers. What we call it as a evaporator coils. Okay. And here we have fan section. So we have this centrifugal or blower fan here we have. Okay. Then here we have one VCR system. So we'll have compressor, which is driven by some motor. Okay. With this compressor, there will be a like condenser. Okay. So what is happening? So we have a evaporator coil. It will be outlet will be inlet to the compressor. So this is a compressor. This is a condenser. So this is a schematic representation. Don't take it, practically they are like this. Then compressor, it will give the refrigerant to the condenser. Condenser will condense it. It will give to the expansion wall. Okay, so this is a like expansion wall. It will give the refrigerant back to the evaporator. So this is our evaporator. Okay. Now what will happen in this case? So this fan or blower, in this case it is fan. So fan will take air from outside. This air will be filtered. It will come in contact with this evaporator coils. It will be cooled and it will be delivered to this room. So there we have, suppose here we have some supply duct. The ducts are used for this system for the distribution of air. And this duct will be here. Then we have some air delivery systems like diffusers, resistors we have. So it will supply the air. Air will circulate inside the room. It will take the heat load. Then what we are using to reduce the load on this system, we are taking some return air. So some return air will be taken from the system. For return air, we have return air diffusers. So they will take the return air. This return air is taken. It is transferred to return air duct. So this is a supply air duct, SAD. This is a return air duct. So this is return air will transfer that air to the AHU. So this is a AHU, air handling unit. This is a return air duct. Okay. So what I have done here, I have taken one room. So I have to cool this room using a DX system. Okay, DX system means that refrigerant will come directly contact with cool air, the air which we are using for air conditioning application. So here we have this VCR system. We have compressor, we have condenser. Okay, and this is its circuit. So condenser will supply this liquid refrigerant to evaporator. In evaporation, what is happening? So here we have one AHU. AHU means air handling unit. So this is its filter. Then we have evaporator coil. Then we have a fan. So air will come in contact with this cooling coils or evaporator coils. Then that cooled air will transfer to environment. Okay, so the cooled air is supplied with supply air duct. It will supply the air inside the room. To reduce the load on AHU, what we are doing, we are using that return air here. That return air is mixed with fresh air. So the equation is there. Fresh air plus return air is equal to supply air. Because what we are doing, we are taking the return air, we are taking the fresh air, and we are supplying it to the room. That is the supply air. So what happens in our AC, जे आपण घरात AC लावतो, तर त्यामध्ये फ्रेश एअर सप्लाय होत नसते. त्यामध्ये काय होत असते? Whatever air is there inside, that is being recirculated. So in that case, what happens after some time, that oxygen level inside the room reduces. We feel suffocating. आपल्याला suffocation व्हायला लागतं आतमध्ये. So we need a fresh air. So in that time, we have to open the doors and let the fresh air come in. Then we can close the door, and with that fresh air, we can again continue our air conditioning. But again, in that case, what happens? Once you open the door, outside air comes in. Then the heat load on the AC increases. Okay, so this is a DX system. I will go for the chilled water system. I will show you that also. So let me add one more slide here. Okay, I have one question. Is the same way AC works? So this water diagram I have showed you. So that is for ducted system. In our home, we don't have ducts. Okay, आपल्या घराचा जो AC असतो, so we have evaporator coils, and on evaporator coils we have a blower. So the blower is continuously circulating the air. That air is comes contact with the evaporator coils, and then it is cooled. So if you take like cross section, so like here it is a wall mounted AC. If you take its cross section, what you will observe here, we have evaporator coil section here. Then we have filters. Filters are also provided in this. If you open that split AC, so here, so let me draw a bigger diagram so you will understand. तुमच्या घरातला असा एक स्प्लिट एसी असतो, ठीक आहे. So what is happening here? Here we have delivery system. इथून एअर तुमच्या रूम मध्ये पास होत असते. So we have guide vanes provided here. So here we have return air. म्हणजे एक रिटर्न एअरची ग्रिल असते मोठी. Okay, so this is like what we see our split AC, that inside section. If you open this, what you will observe, first will come, so I will start from inside to outside to inside. So first you will observe one filter is there, so this is a filter. Then we have a blower, so blower also. So you know that this blower, or I will take that also, fans and blowers. So it will continuously take the air inside. Then we have a heat exchanger, that is the evaporator coils. Evaporator coils are there. It will come in contact with evaporator coil, it will get cooled. Then that blower will supply the air again. आता परत मग ते एअर डिलिव्हरी सिस्टीम मधून ते एअर बाहेर पडेल. आणि इथं तुमची काय असते, रिटर्न एअर सिस्टीम. तर रिटर्न एअर घेईल. So that return air will be taken inside, it will come inside in direct contact with the evaporator coil, and that cooled air will be supplied. Okay. So quickly we'll take for this central chill water system also. So as I told you, this works on the secondary refrigeration. What is happening? Evaporator first will cool water, and then water will cool air. So this is generally used in multi-storage building. So I'll draw one building here. So this is some kind of cut section of the building. This is a G+1 building, that is ground floor plus one floor extra. So this way, this architect people talk G+8, G+10. Then we have here ground level here. Then this is your finished floor level 1. Sorry, not this. This is a false ceiling. Okay, so this is your finished floor level 1, and this is your finished floor level 2. If you have one more floors above it. Then I want to cool this system. ठीक है, मला ही system cool करायचे. I will write this notations on right side. So here it will be FFL1. This will be FFL2. Okay. So first I will have one what we call it as a VCRS system. Okay. So I will have one compressor. Driven by a motor. Okay. Below this I will have a condenser. So below this I may have evaporator of VCRS. So this is a compressor. This is a condenser. This is a evaporator. So how the circuit will go? So compressor will supply that vapor refrigerant to condenser. Condenser will condense it, and it will supply to, let us say, one expansion wall. Here it is. The expansion valve will supply to the evaporator. Okay. And that evaporator will again take out this refrigerant and it will supply to the compressor. So this way that circuit will occur. So this is the expansion valve. Now in this case, what is happening? We are using a chilled water system. The chilled water system is what? So we are using water connections here. Okay, so let us assume these are the water connections, and it is supplied to every building. So suppose in this room, so this is a room 1. We have one AHU here. AHU I have showed in the last figure, and I have AHU 2 here. Okay, so these are these filters, and this is it evaporator coil. So this is a AHU, let us say AHU 2, this is AHU 1. In this case, this will be the filter, this will be the evaporator coil. Okay. Now what I will do, see this is your VCRS system. Evaporator will cool the chilled water. So this is the chilled water CHW in. That water will be cooled. So we have CHW out. Okay. So there will be a piping network inside a building. So this pipe will go up. This will go up. Okay. It will supply this chilled water to this evaporator here. It will take the return line. So this is a return line. This is a supply line. It will similarly provide refrigerant to this evaporator 1, and that return refrigerant or that chilled water, it is taken to return line. So we have supply line, we have a return line. Okay, again that from AHU, what will happen? We'll take out the supply air duct and return air duct. So this will supply air duct here. So I know it looks very complicated, but I'll try to make it understandable. So this will supply the air, right? Then there is a return air diffuser. It will take the return air. That return air is supplied through return duct. So the return duct will take the air to the AHU2. That cycle will repeat. So return air duct will come here. It will supply the air. So this is a return air duct and this is a supply air duct. Okay, so this is a chilled water system. We have a VCRS system first. It will cool the chilled water. Then chilled water will go to the AHU, and that case that air will come inside. Air will be in contact with chilled water. Then that cooled air will be supplied to the room. Okay, so I hope you understood what is the concept of primary and secondary. Primary is our refrigerant, that is maybe R12, R22. Secondary is our water. Specifically, it is called as brine because it is a mixture of ethylene glycol or propylene glycol. Okay, so this was our primary and secondary refrigerants. In next lecture, we'll see what are the properties of refrigerants and how these are classified, how these are numbered. Okay, so I have two questions here. This system will provide same temperature effect as we using common VCR system in both rooms. Same temperature effect as we using common VCR system. Yeah, so VCR system will give one evaporator temperature. So this evaporator will give some evaporator temperature. Let us say this is giving 7 degrees Celsius. Then chilled water come in, chilled water out. So suppose supply chilled water temperature it is 9 degrees Celsius. So it will be same for each AHU. आता ह्याला पण तुम्ही 9 degrees देणार आहे, ह्याला पण तुम्ही 9 degrees देणार. So inlet will be 9 degrees Celsius chilled water. Inlet will be 9 degrees Celsius chilled water. Outlet, suppose outlet comes out to be let us say 15 degrees Celsius. In this case also it will be 15 degrees Celsius. So it depends. Yes. So sorry, it depends on the application. Suppose this room is having lower load. In that case, the temperature may be lower. suppose like 14 degrees Celsius, and suppose here room load is high. Because why load is high? Because there is a terrace comes direct contact with sun. In that case, that water temperature may go up. So it may go up to like suppose 18 degrees Celsius. But thing is, whenever it comes in contact with evaporator, it is made sure that living temperature will be 9 degrees Celsius. So like it depends on the application, but that you can see here, VCRS ensures that evaporator works at 7 degrees Celsius. Now it depends on the chilled water, whatever temperature they are gaining after the heat exchange in the evaporator. So whatever you are asking, same temperature effect, that effect depends on the heat load. Okay. जर इकडे हीट लोड जास्त असेल तर तुम्हाला तसा टेम्परेचर डिफरन्स साठी तसा एएचयू तुम्हाला इन्स्टॉल करावा लागेल. जर इथे हीट लोड कमी असेल तर त्या हीट लोडला तुम्हाला एएचयू वन डिसाइड करावं लागेल. देन यू विल गेट दॅट टेम्परेचर इफेक्ट. सो इट वर्क्स इन रिव्हर्स डायरेक्शन. तुम्हाला पहिल्यांदा हीट लोड काढावा लागतो, त्यानंतर तुम्हाला एएचयू डिसाइड करावा लागतो. एएचयू डिसाइड केल्यानंतर तुम्हाला चिल वॉटर सिस्टीम डिसाइड करावी लागते. ती डिसाइड केल्यानंतर तुम्हाला व्हीसीआरएस सिस्टीम डिझाईन करावी लागते. सो इट वर्क्स इन रिव्हर्स डायरेक्शन, नॉट इन लाईक सिंगल डायरेक्शन. Then how to keep two rooms at different temperatures? So it is like advisable if you are using for air conditioning application. Generally, it is maintained at 25 degree Celsius, right? So that AHU will be designed such a way that will give you the outlet air that is at 25 degrees Celsius. If you want to maintain at different temperatures, suppose if you want to maintain ground level at 30 degrees Celsius, again it will depend on the AHU. Okay. So even though water temperature is 9 degrees Celsius inside, the evaporator or that AHU design will decide how much temperature should be out. So that will study in second section. Don't worry. It depends on that coil section. जेवढे तुमचे coilचे टर्न्स असतील, तेवढं तुमचं जास्त heat transfer होईल. जेवढे तुमचे त्यावर plates असतील, तेवढं तुमचा heat transfer वाढेल. More the heat transfer, lower will be the heat temperature. Okay. So that was not our today's point. So today's point was primary and secondary refrigerant. I'm glad that you have asked questions. Asking questions means that you are paying attention. Uh, uh, okay. So with this, our today's lecture ends. So let me take quickly attendance. Next lecture, we'll study refrigerants in detail. So just bear with me for some minutes. I will take the attendance. Wait.